In this lesson, we'll take steel drawings from setup to delivery in ideCAD. We'll run a clash check, configure view rules and scales, and auto-generate 3D plans, axes, elevations, assemblies, and single-part drawings. You'll see auto-numbering, location and distribution tables, and quick edits in the 2D CAD workspace. By the end, you can produce clean, office-standard steel drawings, ready to print and issue. First, I went to the Drawings tab in the top toolbar and clicked on it once. Let's quickly review the menu that appears. You can see the icons for reinforced concrete, steel, and formwork drawing structures in sequence. These allow you to adjust the drawing settings for each type. We'll get into the details in a moment. The drawing module in ideCAD offers a full-featured 2D CAD environment, designed to support technical drafting with precision and flexibility. Inside this module, you'll find all the essential tools for two-dimensional drawing, such as line, path, circle, arc, and three-point arc. You can also add revision clouds and access editing commands such as move, rotate, mirror, or even rotate building. There are tools for scaling, trimming, and extending, as well as options to create and explode blocks, offset, divide, join, and clone elements, allowing you to modify your drawings just like in a traditional CAD platform. For dimensions, the Free Dimension tool lets you add or adjust annotations, with advanced control over angles, radius, and labels. This entire toolkit is tightly integrated into ideCAD's modeling workflow, so you can create, edit, and annotate 2D views in parallel with your BIM model. Before we dive into the steel drawing settings and review the drawings, I'd like to talk about a key preliminary check, clash check. To access it, I go to the Analysis and Design tab on the top toolbar. Then, I click on the clash check icon. This command allows you to detect any potential conflicts in the model that could impact the drawings. For example, two bolts might be overlapping with each other. A bolt might be intersecting with a plate. Two plates might be clashing. A plate might be colliding with a main steel member. Or a bolt might be intersecting with a main steel element. You can identify all of these situations precisely, down to the millimeter. I clicked the command once to start the check. After running the check, a detailed clash check report has been generated. To better visualize the issues, I filtered out the claddings. Then, I clicked on the first row in the list, and as you can see, the two clashing elements are automatically highlighted in red. Zooming in a bit, we can clearly see that the beams connected to the column along its strong and weak axes are intersecting with each other. This is because no connection has been assigned between either beam and the column. Let's select another error from the list. This time, the clash is between a main steel beam and the top plate of a connection. Both elements are shown in red. To resolve this issue, we need to insert a proper connection between the main beam and the column, and if necessary, fine-tune the beam's elevation. Additionally, as clearly visible on the screen, two purlin connections overlap with the top plate. To fix this, the offset distances of the purlins should be adjusted appropriately. Once we've reviewed and addressed all the issues on the list, we can proceed with generating the steel drawings. For now, just to save time, I'll go ahead and generate the drawings as is. But under normal workflow conditions, it's essential to review and resolve all of the clashes listed here. Some of these clashes are also easy to spot in the 3D perspective view. For example, we can clearly see how the diagonal brace intersects with the column section. Let's move on and proceed with the drawing phase. Let's now go ahead and open the Drawings tab from the top toolbar. I hovered over the steel section and clicked the arrow to expand its menu. Here, you'll find several configuration options before generating your drawings. At the very top, we have Steel Drawing Settings, where all general and detailed drawing preferences are defined. If there's a specific location in the project where you'd like to generate detailed point drawings, you can select that region and add it to the point details list. Below that, you can see a full list of all the available drawing types. Single part drawings. Assembly drawings. Assembly drawings with single parts. Column anchorage drawings. Application plan drawings. Axis and frontal view drawings. Roof plan drawings. Truss drawings. 3D isometric view drawings. General construction drawings. If you want to generate all of these drawings combined into a single sheet, you can choose the General Construction Single Parts and Assembly option at the bottom of the list. When this option is selected, the software will automatically optimize the layout and prepare a complete drawing set that follows a logical and consistent sequence for technical documentation. Let's begin with the Steel Drawing Settings at the top of the list. I clicked on it, and the Settings window opened. Under the General tab, you'll find color and pen width settings for different object types such as reinforced concrete, steel columns, steel beams, secondary beams, and trusses. These colors also represent line thicknesses, ensuring the drawings are prepared with the correct output appearance. If you want to generate drawings only for a specific group of elements, you can use the two selection checkboxes located here. Just like generating all drawings for the entire project, you can also select only a set of elements and create drawings specifically for that group. On the right side of the window, you'll see the scale settings. Here you can define scales for element views, plate views, plan drawings, axis drawings, 3D drawings. If needed, these scale values can be adjusted individually. By default, the background color is black, and the sheet size is currently set to A1. You can switch between A0 and A4, or define a custom sheet height and width depending on your needs. At the bottom, there are orientation options. You can choose portrait or landscape based on your project's layout. Now let's explore the Text tab. This section is especially useful if you or your office follow a specific set of drawing standards. You can customize the text style, arrow types, mark types, text and line colors, and font preferences used in the drawings. The same applies to dimensions, view names, and axis labeling. You can configure all related text and label settings here as needed. Now let's move on to the Views tab. When I go to the View Selection section, you'll see two separate lists for single part and assembly drawings. In both lists, front view is enabled by default. Let me emphasize this part. When you click on any of the view rows, a new window opens where you'll see three options: Open, Closed, Automatic. So how should you decide which one to choose? According to technical drawing standards, certain views must always be included, and those are typically set to Open by default. However, if a view should be generated only when there's something meaningful to show, such as an additional connection, operation, cut, or detail, then Automatic is the ideal choice. When you select Automatic, the software will check the view content and generate it only if there's a connection, trim, extension, or any other relevant component that should appear. If you set it to closed, that specific view will not be created, even if there's content that could be displayed. For example, in the current list, the back and bottom views are closed. So those views will not be included unless we manually switch them open. Below these view toggles, we also have rotation angles for X and Y axes, as well as section depth. These parameters let you fine-tune how each view is generated and how deep the cut will be within the drawing. Lastly, on the right-hand side, you'll see a set of additional options. I won't go through every single checkbox one by one, but keep in mind. You can enable or disable each feature by simply checking or unchecking the boxes, depending on your project's needs. Here, for example, you can choose options like Show bolts on isometric view, Draw bolts in 3D on isometric views, or Fill bolt holes with hatch. Depending on the drawing type, various options can be activated, such as displaying length text on plan and axis drawing labels. Adding location labels to assembly drawings, or including distribution tables in single-part drawings. We'll see the effect of these settings in the generated drawings shortly. As I mentioned, you can enable or disable any of these options depending on your needs. At the bottom, we have settings related to point details. For example, you can choose to show point details in plan views. Or, if you'd like to include detailed connection point views in axis drawings and frontal drawings, you can enable those as well. Now moving on to isometric viewpoint options. At the moment, I've selected Show all point details. But if needed, you can display only a specific group, or choose not to show any of them at all. Next, I've opened the Story Levels subtab. Here, you can select whether the level names should be displayed on the right or left side of the drawings. You can also add level markers as needed. You have full control over the text height and color, line color, and font settings. Additionally, you can specify where exactly the level line will appear, and customize details like text color and line type. Moving on to the Annotations tab. The software provides predefined annotation types that include technical notes commonly used in steel detailing. You can choose one of these presets or create a new one using the Create New option at the bottom. You can switch between annotation types and freely edit the text inside each one to suit your project needs. This makes it easy to customize your annotation style and content. Finally, let's take a look at the Axis Drawings tab. All the grid lines defined during modeling are automatically listed here. The default values for both positive and negative depths are set to 50 centimeters, but you can easily adjust them from this section if needed. Now, let me explain when you might actually need to make such adjustments. If you're working with a structure that has a curved or inclined form, modifying the depth values might be essential to capture the geometry accurately. To simplify this process, the software automates it for you. It treats purlins, girts, and claddings as boundary elements in both axis and plan drawings. Based on the geometry of these elements, the software automatically identifies the outer surfaces and the roof of the building, and generates the corresponding roof plan and elevation views accordingly. You'll see how this works visually in just a moment. But for now, if there's any axis drawing you don't want to include, simply uncheck its corresponding box. Now let's move on to the plan drawings. As you can see, the drawing levels for all stories are automatically listed here based on the story settings. The default positive and negative depth values are also set to 50 centimeters, just like in Axis drawings. You can hover over each entry and modify the values if needed. If you need to generate a plan drawing from a different elevation that's not already listed in the story settings, just click the Add button at the bottom. This lets you define a custom elevation for additional drawing generation. I'll go ahead and select all the available drawings, and now I'm clicking the Generate button. At the bottom, you can see the process steps the software is running through. It starts with automatic numbering. The drawings have been generated. It starts with the 3D drawings. You can see the isometric view right here. Then, the anchorage layout is displayed. You can clearly see the distances between the grid lines, as well as the total length along each side of the structure. The drawings are cleanly detailed, and the anchor plate is automatically numbered. Next, we have the application plan drawings. Here's the drawing for the 0 level. As you might recall, I added an extra elevation at 150 centimeters, and now that drawing is also listed here. Additionally, there's a detailed plan view at 3 meters, showing all relevant elements cleanly and accurately. The stud layout for composite slabs is also visible on the screen. Then we move on to the axis drawings. These include axis names and distances between the grid lines. As mentioned earlier, for both the roof and elevations, the software automatically determines the building envelope by analyzing the purlins, girts, and sheetings and generates the corresponding drawings accordingly. For example, here you can see the roof framing plan with diagonal braces, purlins, and ties. Sag rods are also listed sequentially. The same applies to elevation views. Each drawing is presented cleanly, with braces, ties, and beams clearly shown. As for the axis names, all details required by technical drawing standards are included. We've already seen the layout for the composite slab. The section view is also generated. At the bottom, the summary table consolidates everything. Similarly, for sag rods, both the cover and the rod itself are detailed in the drawings. Now let's move on to the point detail drawings. Here's the plate detail for one of the anchorage assemblies. We continue with assembly drawings and sheet generation. The software automatically generates sections and places dimensions on the drawings. Of course, you can manually edit these drawings as needed. Since it operates like a 2D CAD platform, you're free to make any modifications using standard drawing tools. Earlier, we had activated the settings to include location and distribution tables in both assembly and single-part drawings. Now you can see the grid layout, and all components placed in that area are listed in detail. When we switch to single part drawings, the views are also displayed along with their dimensions. That's the general workflow for the drawing process. On the far right, under the tool icon, you'll find both the steel numbering settings and the perform numbering commands. However, you don't need to click perform numbering manually. The software automatically runs the numbering process before generating any drawings. Let's take a look at the settings. Here, you can see all element types, columns, beams, secondary beams, etc. You can configure the naming formats for single part and assembly drawings based on your project or office standards from this panel. Thanks for watching. Don't forget to like, subscribe, and explore the knowledge base for more tips. See you in the following video.